Hi everyone. After studying many topics about induction motor, now we come across writing torque equation for induction motor, three-phase induction motor especially. So this torque equation plays a major role. So here we talk about torque at standstill, torque at running condition also. So many conditions we study, and this will be helpful for you to understand the next topic called torque slip characteristics of three-phase induction motor. Now let us go ahead and write more equations for torque equation for the induction motor. So here the torque equation. So torque is generally proportional to current. It is proportional to the flux because so as we studied in this one, rotating magnetic field theory, flux produces current, and the angle between both of them is cos phi 2. So torque is proportional to phi into I2 into cos phi 2. So it doesn't end there. We still continue it. So as torque is proportional to phi into I2 into cos phi 2, but the flux phi is produces E2, or the cost for production of E2 is the flux phi, so which are proportional to each other. So in place of flux phi, I substitute E2. You'll be getting it out. What is E2? What is I2? E2 is the EMF produced in the rotor. I2 is the current produced in the rotor, and cos of the angle between them is cos phi 2. So this is your torque is proportional to E2 I2 into phi 2. You can see this equation, you can relate it. So torque is a mechanical quantity. E2 I2 cos phi 2 looks like active power. So here, torque is something which is mechanical power, and here E2 I2 cos phi 2 is something regarding to your electrical power. So what are the different kinds of things which we are going to study about the torque? First, we talk about what is starting torque, what is the condition for the torque, what is the condition to get the maximum starting torque, and later we study about running condition, what is the maximum torque under running condition, what is full load torque versus maximum torque, starting torque versus maximum torque, the ratios which we are going to find. So these are the things which we are going to discuss after having this equation. So now R2, as I said, rotor resistance per phase at standstill. X2 is reactance per phase at standstill. Z2 impedance. Z is equal to square root of R2 square plus X2 square. We continue with the previous equation here. Now let us continue. So I keep a constant K. 3 is equal to K into E2 I2 cos phi 2. So this is what which we kept. But what is I2? According to Ohm's law, I is equal to E by Z. I is equal to V by R, E by Z, E2 by Z2. E2 divided by Z2 is this value which I keep. E2 divided by square root of R2 square plus X2 square. 2 is missing here. Cos phi, according to impedance triangle or any triangle, cos phi is equal to R by Z, R2 by Z2. R2 divided by R2 square plus X2 square. The suffix 2 is missing here. So I substitute these two things in the above equation. K into E2 by square root of R2 square plus X2 square into R2 divided by square root of R2 square plus X2 square. So torque is equal to K into E2 square. E2 and E2 multiply, they become E2 square into R2 divided by R2 square plus X2 square is the equation which you are going to get. Now you know this. So this is the equation. Now I get the value of K, which is a constant value which relates the mechanical on the left hand side to electrical on the right hand side. This is your complete torque equation. The starting torque I can say, which is 3 divided by 2 pi ns divided by 60 into E2 square into R2 divided by R2 square plus X2 square is the value which we are going to get. And now, so this is your starting torque and this is the torque. And so here, so E2 is always a constant value. So this is the value. I keep it as K here, but E2 is constant value. I take this K into E2 square as K1. So starting torque is equal to R2 divided by R2 square plus X2 square is the one which you are going to get. So this is your starting torque actually. So now we are going to derive, that is the finalized equation for starting torque. So now we are going to derive the equation like what is the condition to get the maximum starting torque. I take this value, differentiate it with respect to R2 and make it equal to 0. So when I differentiate, I keep U by V formula, U into integration of V minus V into U into differentiation of V minus V into differentiation of U divided by u square, the denominator square. So the denominator multiplies, and doing the mathematical calculations, the condition for maximum starting torque is R2 has to be equal to X2. What is your R2 again? R2 is the resistance of the rotor. X2 is the reactance of the rotor. Those two things should be same. Then it is called as the maximum condition for the starting torque. So we can get the maximum starting torque at the condition whenever R2 is equal to X2 actually. Now we go with running condition. When the rotor started running, as we discussed, whenever the motor starts running, there is a slip, there is a lag between synchronous speed and rotor speed, that is called as a slip. So I call it as like this. So E2 is designated as S into E2 from now onwards. So E2 X2 is designated as S into X2 because they are all frequency dependent terms actually. I is equal to E2 divided by Z2, E2 divided by R2 square plus X2 whole square. Cos phi is R by Z. R divided by Z is R2 square plus Sx2 whole square. Now again, torque is K E2 I2 cos phi 2. What is this? K E2 I2 I substitute in the current equation. So it becomes S actually. Here S has to be kept. S into E2 divided by square root of R2 square plus Xx2 whole square. R2 divided by square root of R2 square plus Xx2 whole square. This E2 and this E2, they both multiply and you get this value. And K is again the same. So this is your finalized or running condition, not starting condition. It is actually running condition, though it is written starting here, it is a running condition actually. Now what is again the condition for maximum torque under running condition? So differentiate this with respect to the zero. You can see here this term, this particular term I take and make it differentiated with respect to the zero. This term, so u by v formula, so denominator goes zero. Finally, previously we got R2 is equal to X2. Now we get R2 is equal to X times of X2. So that is the condition for maximum resistance, slip times of rotor reactance. Previously R2 is equal to X2, resistance is equal to reactance of the rotor. But here resistance of the rotor has to be slip times of reactance of the rotor. So now whenever I keep R2 is equal to X2 in all my equations, in all my this equation, R2 has to be replaced by X2, Sx2. So you are going to get this equation. And here, you can see Sx2 whole square. So this is the finalized equation which I'm going to get. So you can see you can cancel off X2 and S square. So torque, starting torque is equal to K into E2 square divided by 2 times of X2. This is the maximum torque, starting torque actually. Now under full load, what happens under full load, you can see. So this is your torque and this is your maximum torque which we have just discussed, E2 square divided by 2 into X2. Now full load divided by maximum torque. So this is your full load, this is your actual value, and this is your maximum value divided by the maximum value is this. So whenever it goes on to the numerator, it becomes exponent actually. So you can see K E2 square gets cancelled. You are going to get this equation. 2s x2 xf into x2 into r2. Here in the denominator, x2 square is taken as common. Sf square as slip at the full load plus r2 square by x2 square. So you can see here x2 in the numerator, x2 in the denominator gets cancelled, and this x2 goes on to the numerator. It becomes r2 by x2. 2s into r2 by x2, s square plus r2 x2 square. So r2 by x2 is termed as a 2a sf divided by sf square plus a square. So that is the ratio of full load torque to maximum torque actually. So now starting torque to maximum torque also we'll discuss. So this is your starting torque. So where there are no SS, and this is your maximum torque. Divide both of them. This becomes reciprocal. You can see here. So K E2 square gets cancelled. You are going to get this value. In the denominator, I take x2 square as common. X2 gets cancelled. 2 into r2 by x2 plus 1 into r2 square by x2 square. R2 by x2 is termed as a 2a divided by 1 plus a square. Previously, we got 2as divided by a square plus s square. Here s has become 1 because it is a starting torque. So these are the values which you have to study in torque equation. So finally, what did we study in this one? So we studied about formation of the torque at the starting condition, at the running condition, and what is the maximum condition for starting torque at R2 is equal to X2. What is the maximum condition of the running torque? R2 is equal to X times of H2. What are the ratios For the starting torque to full load torque or the running torque to full load torque, we discussed. We got 2as divided by a square plus a square plus s square, or 2s divided by s square plus 1. So these are the things which we have discussed in this torque equation. So thank you all of you. Hope you understood this video. And this video is specially meant for torque itself. Thank you everyone.